evening, good morning, everyone. My name is Espen Braekken, and I'll start the presentation now. So, downtime in MySQL emergencies, what are we talking about? The agenda, the way I want to do this is first talk us through a little bit about what high availability really is. Then I'll discuss downtime and causes of downtime as we have found in our research. And then we'll move on to give you some ideas of how you can prevent downtime. I say some ideas because it's a quite big topic, and we will point you at the end of the presentation to some resources that we have that details this in a, with lots of detail. And this is just to give you an overall idea of the structure of, how you would go about to prevent downtime. Now, let's start with the high availability discussion. The high availability can really be described as absence of downtime. And typically there's like two buzzwords being used repeatedly when we talk about high availability. That is MTBF, mean time between failures, and MTTR, the mean time to repair. So the MTBF defines the frequency of your failures, and the MTTR defines how long it takes you to get back online or into business, if you like. And if you look a little bit more at the first at the time to repair, you will see that there's really two things that defines how long it takes to repair. One is how quickly you figure out that something is wrong, and the other one is how quickly you're able to recover. And it's an interesting observation that in many cases, most people and organizations focus on the technology aspects of that, and that tend to be very limited and very reactive in nature. And if you look at how we can increase the mean time between failures, i.e. reduce the rate of failures, it's a different picture. Here, it's really, we call it here boring. This is the hard work, hard to justify, proactive approach where you understand, you spend time to understand failures, you really do proper research, you do postmortems, and you actively work to prevent or reduce future failures. So that leads us to the goals of this presentation. We want to see if we can give you a good idea of why downtime happens, give an idea of which failures are most common, and talk about what could have been done to prevent these incidents. So just brief stop here at the big word, proactive, used a lot, and sometimes maybe without really thinking what it means. It really means that we intervene in or try to control an expected occurrence or a situation, and typically we're then referring to something which has a negative impact. So let's move on then to the part where we talk about downtime incidents. And first, let me give you some background. Percona has been in the business of helping customers with MySQL and LAMP-related challenges for more than 5 years. And as such, we have a pretty large database of cases that we've worked on in the past. Our Chief Performance Architect, Bernd Schwartz, pulled 200 of emergency issues from our case system and started looking at them. He discarded some, and he had 154 that he kept for further analysis, and he categorized them based on location, cost, and potential, what could have been done to prevent the failure, and then ranked all these by frequency. And as you can imagine, before he'd done all that, it pretty much looked like this, a very mixed picture. Having done the organization and categorization, this is what he ended up with. I'll let you just take a brief glimpse of that while I take a sip of water here, excuse me. Now, so here we see, out of the 154 cases, the distribution, after we have categorized them into 4 main categories. What we call the operating environment, what we call performance, and then we have replication and data loss. So operating environment and performance account for roughly 35% each. Replication-related things, 20%, and then data loss and corruption around 10%. And this is, again, there's lots of detail in the supporting documentation that we will point you to at the end of the presentation. So what we've done here, to give you a glimpse, and I'll spend a few minutes talking about this. We've selected the top 10 incident types within each, across all the categories, I should say. So this is, out of the 154, what we're talking about here is this sums up to 98 of the 154 cases, i.e. roughly 64%. So it's really the main reasons for emergencies with our customers. And this is probably a good time to add a little disclaimer. Of course, us being a third party providing support services, we would be exposed to certain types of problems. Customers would contact us for difficult problems, and also to some extent, the type of customers we have will determine the type of problems we're dealing with. Traditionally, we've done a lot of work for web type properties and companies who may have, put a premium on execution speed more than, for instance, process. So that may also reflect how the distribution here, but we still think this is certainly relevant data. So if we just walk through the list from top to bottom here, we see that SQL, poorly formed SQL that does not perform is a huge contributor to the emergency cases. We see within the replication category data difference. This typically happens when something goes wrong in the configuration and writes happen to so-called read-only slaves and things like that. In the data loss and corruption category, we see one single command, the drop table command, being the most, it's probably overall in this whole data set, the single most, or the top dog in terms of cost here, and obviously very easy to avoid by assigning privileges properly and making sure that people know which systems they are connected to when they perform these destructive operations. In the operating environment category, we see disk full. Yeah, I mean, it's easy to discover, but of course, if it happens, it can have serious consequences. If it's a system disk, it can bring your entire system down. Also in the operating environment network, there are different types of networking problems, including having configured MySQL to rely on DNS. That's the default behavior. You should disable that, called skip name resolve. If you don't, if there's a DNS failure, your system will pretty much behave as if you're under a denial of service attack. In the operating environment category also, we have operating system, failure to upgrade, apply new patches, old kernels, wrong I/O schedulers, and things like that. Performance category, schema indexing, typically rolling out new table changes or schema changes without testing first, poor or no indexing, and also poor choice of data types that don't necessarily lend themselves well to indexing. In the InnoDB category, we have seen lots of problems with people running with plain vanilla built-in InnoDB on 5.0 and 5.1 instead of the InnoDB plugin, or you could also use Percona server. In the configuration category, typically running with just plain vanilla setup and not having done anything. In one instance, we had a 64 gig RAM server that was running with the default settings, DB buffer pool of 100 megs, for instance. And finally, there in the replication category, configuration-related issues typically associated with not setting an important network parameter that allows for large packets to be transferred, and also, in many cases, running with different parameters than you have in your config file. So having dynamically set parameters, that is, so in case of a failure and a restart, server starts with different settings and replication stops working. And again, I encourage you to read the supporting documents. There's lots of detail here. Now, if we talk about, so why did this happen? What's really the root cause? And we're really not sure that there's such a thing as a root cause. There's typically a chain of failures, and more often than not, a single intervention will have caused prevention. So, for instance, in the case of disk full, if someone had actually just looked at done an LS or DF and seen that the file system was about to fill up, it would have been easy to go in and remove log files or compress or whatever, right? So that is typically the case. And if you were to say, hey, so what's the number one cause? And then we have two here, because this is an interesting observation. What we see, or what we think we're seeing here, is really this: that lack of change control is a major contributor to these type of emergencies that we're seeing. And typically in an upgrade scenario, but not necessarily always. That means applying configuration changes or schema and query changes without testing first. And we also see in the area of upgrades, we're talking software upgrades here, and then typically, MySQL software upgrades, that people are upgrading carelessly. Going from 5.0 to 5.1 without testing. You will see query behavior changes, i.e. you get different results. You will see that query plan changes, i.e. execution under the hood changes, and it typically is slower. And you will encounter bugs and so forth. And on the other hand, we also see some customers that just pretty much fail to upgrade. And if you do that, you're really vulnerable to bugs and bugs. It is a problem. I was just checking yesterday to make sure I had the revision numbers correct. So in the 5.0 series, we're now at 5.092. On 5.1, we're on 5.161, and on 5.5, we're on 5.5.20. And there's very, very, very many problems with it, especially with early 5.0 versions around replication, but also other things. So certainly going from 5.0 to 5.1 series is non-trivial, but within a series, unless there is a specific reason for you to stay at a revision, at the lower revision, you should go to the highest revision as a rule. Okay, so let's move into the discussion of what you can do to prevent and how you can be proactive. And again, mixed picture, ask 10 people what you can do. You get 10 different responses, at least 10 different. So here's what we're saying. This is kind of like the good news and the bad news. The good news is it's easy to do. The bad news is it requires routine activity, and it really doesn't have a lot of flair to it. To be proactive, you really have to do something on a routine basis. For it to have value for you, it needs to be documented, and you need to find the appropriate schedule for these activities. Just give you an example before we talk in more depth about this. So this is also from the supporting documentation, a typically checklist, and in this case, my favorite topic, backup and recovery testing. So instead of, in your documentation, instead of saying, yes, I have tested backup and I know it works, this says, I have done a restore, and these are the results. I've done a point-in-time recovery, these are the results, and these are the side effects on the system in terms of CPU utilization and network and so forth, how long it took, and you record everything so that if something happens, you don't only know that you can recover, but you know how long it takes. And if you do this on a regular basis, say for instance monthly or quarterly, and you see the trend in terms of that the recovery takes longer every time, it is very, very valuable information. So let's go into more detail here. Excuse me. So scheduling, we like to break this down into 4 different type of schedules: one-time tasks, weekly, monthly, or those irregular on-demand tasks. And on the following slides, we're going to list some of the main points. And again, this is a topic we could talk about at length and in great detail. So we want to give you an overall idea, and then please see the resources for more detail. Now, for a one-time task, this is typically when you set up your servers to go into production. Important steps here is to verify the relationship to external systems, make sure that everything related to storage and privileges, both the infamous drop table, but also things like sudo rights and so forth are probably taken care of, and also that basic configuration settings are taken care of. If you're on a Red Hat type system, should SA Linux be activated, yes or no? You should set up monitoring and alerting, and we want you to be frugal. What does that mean? Well, in our experience with emergency cases, and once things calm down a little bit and we've got things under control, typically someone asks the question, hey, I thought we had some type of monitoring on this. Why didn't we get alerted earlier that something was wrong? And in that, following that, typically one of 2 things happen. One thing is that people start digging around and figure out that, yeah, well, there was an alert, but the email got blocked in a firewall or something, or a spam control in an email server. Or, on the other hand, someone suddenly says, yeah, there was an alert, I saw that email, but I get 200 every day, so I just ignore them. So it's very important that you really just monitor problems or things that are true indications of problems, and not anything else. When we look at things, metrics and trending, however, it's a completely different picture, and we want you to capture everything, literally everything, or as much as you can, and also keep it as long as it's practically possible, because this is you really don't know which items, which data elements you might be interested in the future when you're going to do some, if you need to do some analysis on your data. On a weekly basis, a very important task is to predict for replication lag, right? So in MySQL, the slaves have, there's a limited capacity, or there's a limited number of operations that a slave can handle, and you want to go in on a regular basis, see how it's doing, make sure it's doing okay, and see if you can predict how it's going to behave in the future. And if you think it's going to fall behind and not be able to catch up again, you need to take action. You should use the data that you collect on a regular basis, the metrics, to do some, fast black box or back of the envelope analysis. And you should look at your workload performance and look at schema, or look for problems in schema, indexing, and data distribution in queries. There are tools to do this. For instance, the Percona toolkit, aka PT toolset, has there's specific tools for all of these things, and also lets you save the data and compare from week to week or month to month. You should also look at new queries and schema changes. In a perfect world, you knew these were coming because you have a tight and controlled release process. In the real world, many times you don't, so you really have to catch them after the fact. Number 3 here, what I mentioned earlier, the difference between what you get when you do show variables versus what's in your MyCNF. Basically, if you've set anything dynamically and not reflected that in the MyCNF, can give you lots of headache if you do a restart, planned or unplanned. And also validate backups. This is just backups ran, there are no errors in the log file. File exists, or the backup file or backup files exist, has the right privileges, and the size seems about right, i.e. it's bigger than the last backup. And you should check for corruption, look at log files, and there are also commands, depending on which storage engine you use, that you can run to validate the integrity of your data. Also, review your logs, improve their work, and verify that alerts get through. This kind of goes back to what I said earlier about alerts not reaching their destination. So in the supporting documentation, Braekken describes how you can simulate a serious MySQL error and have that show up in the MySQL error log. And this is a simple command you can run, and you should see that the error gets written to the log. Following that, assuming you have some type of alerting or monitoring, that should get picked up by, say, for instance, Nagios, and being sent to its final destination. So this is a very easy way for you to test that if serious stuff happens, your alert or monitoring picks it up and you get the alert. And also finally check to see if it's time to restart. Some servers, it's fact of life, many servers behave better after a restart, but there's also fact of life that some servers fail at the time of a restart. So if you can do this in a planned manner, it will make life much easier for you. On a monthly basis, you really want to check that your backup and recovery procedures and your policy is up to date, as in sync with your company or organization goals and with your regulatory requirements. You should test your restore recovery, and I mean test. That is, do restore to a different server, recover to a point in time, and make sure it all works. And of course, if your fail scenario in your failed scenario, you think you're going to recover to a different DC, for instance, you need to test that as well, or instead. Review privileges and security. It's a fact of life again. People move around in organizations. Some people may have privileges they don't need anymore. And again, developers don't need drop table on production systems. Also, review your archiving and purging plan. This is kind of related to the first item there. Typically, when you start out, or you often want, from a technical perspective, as little data as possible lying around. From a business perspective, maybe you want as much as possible, and then you have, again, regulatory requirements which may force you to have the data or even force you to get rid of data. So you really want to make sure that this is in alignment with your company or your organization's goal. And then also just, look for the old stuff lying around that don't have any value anymore, test tables, test databases, and so forth. Just get rid of it. And finally then, on the irregular and on-demand task, check and verify schema changes. If there's a new version of critical software that you're using, review the change logs. This may tell you, woo-ha, that bug you've been waiting for to be fixed for a long time is finally fixed, and you want to fast track an upgrade, or it may even tell you that there's something going on that you really don't want to go to this, and you want to wait for next point release. Again, this may be look for good times to restart systems. Test your upgrades. 5.0 to 5.1, for instance, is a pretty major upgrade, and someone responsible for databases can start doing that a long time in advance to gain a proper understanding and knowledge about all the quirks of such an upgrade. And of course, you get new servers, go back to start and apply the one-time tasks. Now, so this is really what we are talking about. The Stephen Covey's 4 quadrants. I'm not familiar with the distribution of people, where you're coming from, those of you who are attending here, but Stephen Covey is a quite famous author in the US at least, and he talks about, he's this 4 quadrants or dimensions about work you do, things you do, which can either be urgent or not urgent, important or not important. And we're talking about staying in this quadrant, the quadrant that gives you most satisfaction to stay in most of the time, at least for most people. This is the quadrant. This is the type of activities. The type of activities would be, helping someone gain a new skill, teaching your kid how to ride a bicycle or something like that. The challenge, of course, here is that this competes with urgent and important. The emergency, of course, would be urgent and important. And then finally, you have number 3 and 4 here down here, which you really don't want to go there, even though a lot do. My background is from the Oracle world, and this is a screen, or similar to a screen I've seen very, very, very many times in the Oracle world. Spotlight on Oracle or MySQL or whatever. In many big DBA environments or database environments, this screen dictates the workflow, which is actually kind of ridiculous. And just to give an example here, on the screen here in the middle it says rows sorted. Sorry for the screen resolution there, but it says rows sorted. Quest has decided that 7 rows sorted per second is bad, i.e. go do something. It doesn't say anything about the overall system health, how your app is doing, how your business is doing, but go run and do something. Please don't go there. Stay here. Work on those. I know it's hard. sometimes this is difficult, but still work on the important and not urgent issues, things like testing, restoring recovery, which you can never test enough, testing application upgrades, looking through logs, reading the notes for new versions, and properly validating and testing new changes, or validating your application changes before you set them into production, and record everything as you go along. So pretty much just like practicing, developing insight and understanding. And this is really what it is to be proactive. It's as we say, it's not really sexy, but it actually does work. So that's the conclusion of the presentation. Before we open up for questions, I just want to mention some of the resources that we have available for you. On the white paper section on our website, there's the two main supporting documents, or the two supporting documents that we base this presentation on. It's the first one there is called Causes of Downtime in Production MySQL Servers, an article written by Baron Schwartz that was published in the Select magazine. This is 8 pages, I think. And then there's a very in-depth walkthrough of behind-the-scenes walkthrough of what that first article describes. And this one is called Preventing MySQL Emergencies. This is 27 or 28 pages. The worksheets with weekly and monthly tasks and all that, it's there, and it's free for you to copy and use. And there's also detailed advice on what to monitor, specifically what to monitor in terms of events in database, events in the OS, and so forth. And we also have a couple of pointers here to interesting reading if you want to learn more about things that go bad, how complex systems fail, and what the dog saw. We also have, hang on, let me see if I can go to next page. Okay. We had a webinar just last week, I believe, with Baron Schwartz talking about replication. We have, as I mentioned earlier, Percona toolkit, which can be used to manage replication, manage your everyday work with SQL code, with plans, with indexes, pretty much everything that a MySQL DBA needs to work with. We have a tool for that. So look there to see if there's, we have something for your needs as well. There's our forum, some mailing list on Google, Google discussions, and also our worldwide training classes. We pretty much do one class per month, either in the continental U.S. or in Western Europe. And finally, the book, as I refer to it as, High Performance MySQL, written by Baron Schwartz, Vadim Kachenko, and Peter Zaitsev. The third edition will be available in April. I have had the pleasure of reviewing it. The second revision or second edition was great. This one is, if possible, even better, so check it out. We also recently launched MySQL Configuration Wizard, the tool intended to help you to get a very good start at that MyCNF file, the stuff you need and nothing about stuff you don't need. So look at that. And also just want to remind you about the user conference, MySQL user conference coming up in April in Santa Clara. And Terry, correct me if I'm wrong, but I believe the breakout sessions were just announced just the other day. So that brings us to the end. Terry. You go, Terry.
If anyone has any questions, please submit your questions now through the Q&A window or the chat window in WebEx. Okay, do we have any questions? We have no questions at the moment, Espen. We'll give it a minute yet, and then we'll end the webinar. A question for you, Espen. What's the safest way to check for table corruption?
Okay. Oh, that's a bit involves question follow-up there. Which storage engine?
Yeah, there's no further details.
Okay.
Oh, MySQL, MyISAM.
MyISAM. Okay, with MyISAM you can actually run command line utilities to verify. Forgot the syntax there, but if I can get we can get that to you. But basically, you can run that offline, not offline, but directly on your system. But with generally speaking, you need to look for these signals in your log files. It's very seldom that you suddenly just get corruption out of the blue. Typically, there was a warning beforehand, so you need to monitor your logs, and then you need to run specific commands for your storage engine. With, for instance, DB. It's a little bit more involved, but it's the fact that this is one of the reasons why you really need to have a proper backup on another physical machine.
Okay, very good. Well, Espen, thank you for today's presentation. One more question. What's the best way to check if MySQL read-write to disk op are taking more than usual time?
How do you know whether MySQL read-write operations are taking more time than normal? Well, this is going back to my, hang on, let me just look at my notes here just one sec. Well, this goes back to the metrics, right? You really need to collect, right? So that when things start behaving different than what you have experienced or what you were expecting, you can start looking at your data. So you need to collect the I/O stats on your file system or your devices so that you can compare when these things happen. And then also you need to make sure that the frequency with which you collect is, that the intervals are, let's say, short enough that you can read something out of it, but not that frequent that it causes problems for you. So that's a little bit of a balancing act. I would say, typically a frequency between 50 and 60 seconds would be something you would start with and collect those data. But the answer is you need the metrics so that you can look at it when things happen.
Okay. Next question. Is there a difference in weekly, monthly tasks between master, multi-master, and slave DB servers? And if so, what might they be?
No, I really don't think so. I always, when I had presented this on a couple of occasions in different conferences and forums, and I always say, well, as long as you do, we say, for instance, that you should do backup, verify, or restore every month, but, in my time, both with MySQL and Oracle, in the Oracle world, I never seen people do it that frequent. So I think the most important part when it comes to those replication setups is that you don't assume that just because you have, for instance, a read-only of some type of master, that this is where you can take your backup, things like that. So you really want to assume that things can go wrong. So in terms of how often you should apply those weekly, monthly, and so forth tasks in such a, let's call it a complex environment, I think would also depend on to which extent, how your app interacts with those, which I actually would like to know a little bit more about before I go into specifics, but it would make sense. Let me put it like this: if your monthly or quarterly, whatever it is, activity involves taking a server out of the loop and doing something with it and bringing it back, you should do it to all your servers. That was a non-answer. I'm sorry. But feel free to contact me. We can expand. So if you let me know a little bit more about your setup.
Okay. Next question. You mentioned the challenges doing a major version upgrade. We are currently on 5.0.91, so more or less the last version in the 5.0 series. It is working fine for us with no concerns or issues. Therefore, is there any motivation to go to 5.1 or higher?
No, not immediately. If it works, I mean, if it ain't broke, don't fix it. I would say, but you are falling behind. So I would say certainly when 5.6 becomes mainstream, maybe sometime during this calendar year, you would be quite far behind, and I would consider doing an upgrade. You have to do it sooner or later. And in the 5 series thus far, the biggest change has been from 5.0 to 5.1 data type, optimizer changes, and so forth. So sooner or later, you have to bite the bullet. But I wouldn't say it's urgent if everything is working fine.
Okay, very good. Espen, thanks again for today's webinar. We will make a recording of the webinar and a copy of the slides available, and we'll send that information out by email in the next couple of days. Thanks to everyone for attending, and have a good day.
Thanks. Bye.
Bye.